In today's video, here is a nice problem that was suggested by viewer. In fact, it's an amazing problem. So here is the following information. So we get the sum of this integer as k goes from 1 to the a of k factorial, which equals the power of 3 to the b, okay? So k is just the arbitrary number which is related to the a. So this how many the number of terms we have, okay? So our goal, since if you find a, that's mean we found everything. It's very important to test the small values of k to give you a nice image for the solutions, okay? Now let's get started. So I'm going to open up this one. So I will have the following. So I get here 1 plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial plus 6 factorial plus 7 factorial plus 8 factorial plus 9 factorial and so on and so forth until we get the last term, which is a factorial. So this one is going to take 3 to the b, okay? All these numbers must be a power of 3 as we have here, okay? Now let's check this one carefully here. So the easiest way to solve this one, we are going to reduce this one to the mod something. But which appropriate value we can reduce this equation, okay? So I think if you, let's check 9 factorial. What is going to give us? 9 factorial equals 9 is multiplied by 8 is multiplied by 7, 6, 5, 4, 3, 2, 1. So how many of the number 3 I can extract here? So 9 contain 2 to the 3 here, you get 2 here, you get 3 here because 3 is multiplied by 2, we get 1 here. So I get 2, 3, 4. This one it's going to be written on the form of, is going to be written on the form of 3 to the 4th is multiplied by the bunch of the numbers. So I'm going to reduce this one to mod area 1. We'll have this one is a congruent to 0 mod area 1, okay? Now let's put this one here. So I get 9 factorial, which is a congruent to 3 to the 4 is multiplied by capital A, which is a congruent to 0 mod area 1, okay? So this is very important. Since 9 factorial is a congruent to 0 mod area 1, which means all the following integers is going to be is a congruent to 0 mod area 1. It's more clear here. So what to do here, I'm going to check 5 factorial. 5 factorial, it's clearly equals 120. 120, it's clearly is the area 1. Area 1 is going to be written on the form of 3 to the 4th plus 39, okay? So let's calculate these values here. So if you calculate all these things here, you get all these terms up to here equals 33, okay? So I will have the following. I get here, so I have this bunch of the terms equals 33. I'm going to add this one on 39 is going to give us 72, but 3 to the 4th I'm going to move it over to the other side to make a nice factorization here, because I see here 3 to the b. I will have a common factor. I will have a common multiplier there, okay? So I will have 72 plus, I will have 33 plus 39, which is 72, plus the rest. The rest I will have 6 factorial plus 7 factorial plus 8 factorial plus 0, which is a congruent because all the following integers is going to be 0 mod area 1, since we have 9 factorial is congruent to 0 mod area 1, okay? Because 10 factorial is going to have 10 is multiplied by 9 factorial. 9 factorial is already 0 mod area 1. So plus 3 to the b minus 3 to the 4th. Now I'm going to take 3 to the 4th as a common factor. I will have 3 to the 4th factor 3 to the b minus 4 minus number 1. Now we'll have a nice thing here. Always we are going to keep b is super equal to 4. Now we are ready to build a nice proof here. So by the way of contradiction, suppose b is super equal to 4. Okay. Now we are going to compare the reminders of this one when you divide the left and the right side of this equation. If you have a same remainder for both sides of the equation, which means we have a solution. If you have a different remainder, which means we have no solution, which means we are going to reach the contradiction. Okay, so it's simply, I'm going to calculate this one, these things. Let's do 6 factorial plus 7 factorial plus 8 factorial. I'm going to take 6 factorial as a common factor. 6 factorial. This one will be multiplied by number 1. This one will be multiplied by number 7. This one will be multiplied by 7 is multiplied by 8. If I'm going to calculate these things here, I get 7 is multiplied by 8, which is 56, plus 8, which is 64. So which means I get here 64 is multiplied by 6 factorial. Now let's calculate 6 factorial. Let's reduce 6 factorial to the mod area 1. So we get 6 factorial, which equals 6 is multiplied by 5 factorial. 5 factorial is already 120. 5 factorial equals 120. 120 equals 81 plus 39. Now I'm going to reduce this one to mod area 1. This is 0. I will have 6 is multiplied by 39 mod area 1. Now I'm going to take this one and replace it here. So this one also is a congruent to 64 is multiplied by 6 is multiplied by 39. All is raised to the mod area 1. 64, we get 64. If you subtract 64 from area 1, I get minus 17. I'm going to use the negative reminders. So we'll get minus 17 is multiplied by 6 is multiplied by 39 mod area 1. Okay, let's use a nice trick here. So we know 6 equals 2 is multiplied by 3. Okay, let's multiply these 2 is by 39. We get as equals 3 is multiplied by 78. We know 78 is a minus 3 mod area 1 because you get 3 number less than area 1. So I get a remainder minus 3 here. Minus 3 is multiplied by this 3 is going to give us 9, minus 9. Okay, so this one equals minus 9 is multiplied by 17, minus 9 is 17. This one is congruent to minus 9 is multiplied by minus 17. Now let's calculate that. I get plus here. 17 is multiplied by 9. I get here 90 plus 63, which is 153. Okay, 153. 153 is clearly 153 equals 162 plus minus 9. 153 equals 162 minus 9. 162 is the same as 2 is multiplied by area 1. We know area 1 is a congruent to 0 mod area 1, which means this one will be 0. So I will have minus 9. So I get here congruent to minus 9. But be careful here. Now this one is a congruent to minus 9 mod area 1. But remember, don't forget 72. 72 minus 9. Okay? 4b super equal to 4. We get this sum as k goes from 1 to the a of k factorial, which equals 3 to the b, implies we get these reminders. We get 72 minus this 9, which equals 63, which is a congruent. This one is a congruent to 63, is a congruent to 0 mod area 1. Okay, clearly it's a contradiction because we have two different reminders when you reduce this equation to mod area 1. Okay, which means the values of b cannot be more than 4, which means I will have available solution is going to be in this set. So you get 0, 1, and 2, and 3 only. Now let's check one by one. Let's start with the big one. So b equals 3. I get 3 to the 3, which is 27. 27. I'm going to calculate these things here. So I get 1 plus 2 factorial, which is 2, plus 3 factorial, which is 6, plus 20 plus 4 factorial, which is 24. If I'm going to calculate this one, it's going to give us 33. 33, it's clearly is bigger than 27, okay? Which means we have no solution for this equation. We tested both sides of this equation. We found we have an inequality. We don't have the equality here, okay? Which means 33 is bigger than 27. So as you add in more numbers, you get more bigger. You will have this equation, the whole equation is going to be bigger, okay? Let's test another value. The following values, I get b equals 2. B equals 2, we get 3 squared, which is 9. 9, let's test this one. 1 plus 2 factorial, which is 2, plus 3 factorial, which is 6. This one is a solution because we get both sides of the equation are equally balanced, okay? Which means we have a solution. So the first solution, so I get a equals, so since we have 3 terms here, which means a is representing the number of terms, which is 3, the b equals 2. So this is the first solution. The second solution, I'm going to check when we have b equals 1. B equals 1, so which means I get 3 equals 1 plus 2 factorial, which is 2, which is 3. We have another solution, which is a equals 2 and b equals 1. Let's check the last solution. If b equals 0, b equals 0, it's definitely I get 3 to the 0, which is 1, which equals 1 factorial, which is 1. So we get the last solution, which is a equals 1. We have one term, b equals 0. Okay. So we found 3 solutions for this equation. So I have done this problem. Don't forget to support the channel. Thank you for watching. I will see you next video. Bye.